Hello students, welcome back. So now we are going to be focusing our attention on KDE plot. The KDE plot, it looks something like this over here. So KDE plot, it basically the KDE stands for kernel density estimation. And you use KDE plot when you want to visualize the probability density of a continuous variable. Now KDE plot, it's a smooth curve. And this is an alternative to your hist plot, your histogram plot. One of the characteristics of your KDE plot is that the area under the curve is always going to be equal to 1. Now, you want to avoid using KDE when your data set is small or when your data set is discrete. Also, if your distribution has some extreme outliers, you do not want to use your KDE plot. So in this particular instance, I'll be focusing on my tips data set. So I'm printing few records of my tips data set. And so these are my few records right here. So let's look at total bill. This is the column that I'll be focusing on. So total bill, I'm just printing out the descriptive statistics of total bill. So it tells me the minimum value of total bill is 3.07 and the maximum value is 50.8. And my standard deviation is 8.9. The average value is 19.7. Okay, so I do the KD plot, just call sns.kd plot, call this inbuilt method, supply your data, supply your name of the column that you want to use. In this case, I'm using total bill column because that's your numerical column. And then you render this plot, and this is how it looks like. You can see your data for the most part lies between, I would say between 10 to maybe 20 or 25. That's where most of my total bill is lying because you can see the curve, like the peak of the curve is over here. And then you can see that the curve is a little bit right skewed. So that tells me that there might be some outliers over here. I don't know. I'm just guessing now, right now. Just by looking at this, you can anytime when you see this skewed curve, that's an indication that there might be an outlier values over here. Okay, so we can also do some filling. So in this case, I'm saying fill equal to true. That's going to fill this curve. And by looking at this curve, you can make some observation that most of the people in this data set, they spend between 10 and 20 on their meal. You can see that between 10 to 20, that's where your most of your data is lying. Okay, and then a few people spend more than 50 bucks. So you can see that there were a few people, not a lot, but there were some people who spend more than 50. That's because your KD curve actually shows a long tail towards the right direction, that is in this direction. That's why I'm making that conclusion. And the distribution is skewed to the right. Again, you can see that the distribution is basically going like this, is skewed to the right. Now let's study the iris dataset, and let's try to do the KD plot on the iris dataset. So I'm printing my few records of my iris dataset. So it has sepal length, sepal width, petal length, petal width, and the species right here. So let's do a KD plot on the sepal length right here. So you can see that my KD plot looks something like this right here. So sepal length, I would say it goes from 3.5 to maybe like 8.9 or 8.8, something like this. Okay, so the sepal length lies between these numbers, 3.5, that would be from here, up to 8.8 according to the KD plot. And most of my sepal length is between 4.5 and 7. You can see that 4.5 would be here. So most of my data is between this to this range. That would be somewhere over here. So you can draw this conclusion by looking at this picture right here. Also, let's say you want to do KD plot for different species, you can do that too. In this case, I'm specifying my U equal to species because there are three different types of species right here. So it's going to do all three different species, KD plot for that. And this is the KD plot for all three species. So you have Setosa, versicolor, virginica. And you can see that for Setosa, that has petal length between 1 and 2.5. That between here to here, this is where my petal length lies for my Setosa. So we can easily identify the species just by looking at the petal length. Now, on the other hand, for versicolor and virginica, there is some overlapping. You can see that there is some overlapping right here. Versicolor actually has a petal length from 2.5 to 5.5. You can see that this goes from here all the way up to here. That would be for this one right here, this curve. This would be your versicolor right here. Okay, and same thing, excuse me, same thing, you can, a similar conclusion you can draw for virginica. Virginica goes from 4 to maybe 7.3 or 7.4. So the amount of area in the KDE is almost same for all the three species. By the way, I don't know if if you're really good at visualization, you can actually notice that the area under this curve and the area under these two curves is essentially same. That should tell you that the number of versicolor and virginica is basically same. And if you look at this area is essentially same as this area right here. So that should tell you the same thing, that the number of Setosa is same as the number of versicolor. You can also perform bivariate analysis on this KD plot. So in this case, I'm specifying data equal to iris, my x equal to petal length, my y equal to petal width. And in this case, I'm specifying my u equal to species. Okay, so now you can see this is how it looks like. So if now if you look at it closely, you can see that this guy right here is sitting by itself. And who is this guy? That is your setosa. So you can clearly identify your setosa if your petal length is between 1 and 2 and your petal width is between 0 to 0.6, I think. So anytime when your data is between these two ranges, that will be a good indicator that it is a setosa. Likewise, you can draw similar conclusion for versicolor and virginica, although there is some overlapping over here. So this is your bivariate analysis. By the way, in this case, if I do fill equal to true, and let's run this, and now you can see this will actually draw the same thing, but this will be a little bit different. You're going to see a little bit more darker. But if you want to back to the rings, you can just comment this line out and run this, and this is going to give you a different visual representation.